I'm Rich Hill, and this is the video on using the Mittler Brothers bender. I've been involved with bending since 1973 in both the electrical trade and in fabricating. And I found that the majority of people use the same bending skills that I started out using. And this is the good old wild guess method. This is where you go get a piece of tubing, you slide it in the bender, and if you want a 20-degree stub, you slide it back and forth, and you go, yeah, that ought to give me what I want, and you bend it up. Then you put it out on the table, you measure it. If it's too long, you trim it off and use it. If it's too short, you chuck it in the boneyard, get you another piece, and try it again. These methods, whether you come out too long or you come out too short, are both time and material wasters. So it's our goal in this video to show you how to accurately use your bender. And when we talk about accurately use your bender, we're talking about plus or minus a quarter of an inch. This plus or minus a quarter of an inch comes from the fact that in creating a bend in a piece of tubing, what we're doing is we're actually shrinking up the inside of the bend. We're compressing the material here, and we're stretching the material on the outside of the bend. Now this has an effect of the way that the piece of material goes through the shoe and the follow bar. As it's going through and we're compressing and stretching, this piece of tubing actually walks back and forth. This is compounded by the fact that the wall thickness is never a true wall thickness, 100%. Now this is a piece of 1.5" 095 tubing, and this means that the wall thickness is supposed to be 95 thousandths thick. But as this piece of tubing was manufactured, it was rolled out in some kind of a process. As they roll it out, it may have some wall thicknesses that are 90 thousandths, and some may go up to 105 thousandths. But overall, it's going to average 95 thousandths. Well, as these discrepancies go through our shoe and our follow bar, it's going to have an effect on how this piece walks back and forth. So it doesn't matter if it's you or me or Mike Mittler or Superman running that bender, plus or minus a quarter of an inch is about as close as you can come to bending. It's not a 100% scientific true method. Before we actually get into the bending process, we need to all get on the same wavelength, and we're going to go through some definitions here so that we're all talking about the same thing. First thing we're going to cover is the actual bender itself. Now the bender has the ram up here, and it's a 25-ton ram. And this ram is what actually does all the work. It's bolted onto the framework here, and if you notice, this top arm of the framework actually opens up. It opens up to allow us to load and unload the shoe, the follow bar, and the tubing itself. The shoe, and this is an 1.5" shoe, and it is actually made out of a solid piece of aluminum. This is a lifetime shoe. This puppy's not going to break on you. When we load it in, we just line up the hole on our ram and our shoe, and we drop in the pin. Next comes our follow bar, and our follow bar is set up with these two little tabs on it. And what the tabs do is they keep the follow bar the same height off the surface as our bending shoe does. Then we can lower the arm and drop in the pin. Later on, when we load in the tubing, we'll also be putting in the horseshoe. And the horseshoe just fits right here on the front and will actually hold the tubing. The whole thing is run by our pump here, and this is an air over hydraulic pump. And all this means is that there's a hydraulic reservoir down here on the bottom. When we put the air to it, the air is used to pump the hydraulic fluid around and expand the ram. This drives the shoe down. When we release it, we just kick it forward and it'll slide right back. This automatic release is a real nice feature. What that allows you to do is it allows you to make your 90-degree bend, and when you're all through, you can just release it and it will pull the ram all the way back. When we get into checking spring back, which we'll be doing in a few minutes here, when you release it, you just need to come up and release it and then right back down. What we're doing there is we're taking the pressure off of the ram but we don't want the ram to retract all the way back down. I need to cover a couple things here that are real important. This ram generates 25 or up to 25 tons of pressure. This pump here can generate up to 10,000 pounds per square inch of pressure. Both of these need to really be respected. Make sure that all of your pins are in and pushed all the way down. The other thing is, take good care of your hydraulic hose here. Don't be dropping material on it. Don't be scraping it up. If it gets worn, replace it. Do yourself a big, big favor and replace it and keep it in good condition. A few of the things that we need to do accurate bending are a level. And this is just a little 9-inch torpedo level that you can get at Sears. And it has the 3 different bubbles, the plumb, the level, and the 45. We also need some type of angle finder. And there's several of them out there on the market to choose from. Probably the most inexpensive is the little angle finder from Sears, and it just has a red arm up here that floats around and tells you what angle you're on. It's about a $20 piece. If you want to upgrade a little bit, you can go to the Starrett. And the Starrett has a bubble here on the one side. On the back side, it actually has the degrees marked out so that you can unloosen it and you can change your degree, find exactly what you want, tighten it up on the back side, set it down, and read the bubble. The one that I choose to use is the digital angle finder, and this is by Smart Level. What it does is it accurately reads to 1/2 degree what your angle is. The nice feature about this is when we get into springbacks, you can dial your spring back in exactly. When we flip this upside down, you'll notice that the reading flips upside down with us. Those are just a few of the things that will make your bending much easier. Since we've got all of the tools covered, let's go to the whiteboard and talk about some other terms. Here's a few more terms that we need to be familiar with and make sure we're all on the same wavelength. The terms are stub height, leg length, radius, developed length, gain, and setback. When we refer to stub height, which can also be called stub up or a rise, all we're talking about is the length between the bottom of the pipe or the bottom of the tubing here up to the top. So it's this vertical measurement here. And that part is our stub up or our stub height or what we call our rise. And when we talk about leg length, it's the horizontal measurement. So it's the back of our tubing here to the end of our tubing. We won't be referring to leg lengths very much in this video, but it's something that I think you need to be familiar with. Then when we're talking about radius, the actual formal name for this is centerline radius. We're going to assume that anytime we say radius, we're talking about the center line radius. So in our bend here, it would actually be the center of our tubing. And it would look something like this. So this is our center line radius that we'll refer to as our radius. Now, the radius is measured from the center of our tubing out here to a point that's on a 45. So when we say a 7-inch radius, we're talking about 7 inches from the center of this tube out here to a point. If we're talking about an 8-inch radius, then this distance would be 8 inches. When we talk about developed length, we're talking about the actual amount of tubing that's being bent in this process. In our example here, the tubing starts to bend right about here, and it finishes bending right about here. This is also measured on a center line. So when we say that we have like 12 inches of developed length, what we're talking about here is there's 12 inches of tubing being used to actually bend this bend up. From here up it's straight, and from here back it's straight. The next thing on our list is gain, and gain is probably the most misunderstood thing when it comes to bending principles. And it's really pretty simple. If we had a straight piece of tubing here, and we bent it at a 0 radius, 90 degree here. In other words, we came straight down, bent it, and went straight out this way. It would be a longer distance between here and here than it would be by cutting across here. And this is like when you were in junior high and you're racing your buddy home, so you're running down the sidewalk and you get to the end of the block. Well, you choose to go clear down to the end of the sidewalk, staying on the sidewalk and turning and going up the next block. Okay, well, your buddy, he's a little ahead of you, and then all of a sudden he veers off and he cuts across the neighbor's lawn. So what he does is he gains some distance on you. He comes out way ahead of you because he has a shorter path to go than you do by staying on the sidewalk and going clear around. Both gain and developed length, we have some very set formulas that we can actually figure out exactly what the gain and the developed length are for any bend that we choose to. And we'll cover those a little bit more in detail later on. That brings us down to setback. And what setback is the distance that you subtract from your stub height to get your shoe to start bending in the proper place. So if we came down here and we wanted a stub height of 20 inches between the top and the bottom here, we couldn't go out and put a 20-inch mark on our tubing, start our shoe there, and bend it up. We would come out way over. The reason we would come out way over is because of the developed length and the gain that we talked about earlier. Remember, the center of our bend is right here. From here up to here, we have 1/2 of the developed length. Since our shoe starts bending at this point, we have to subtract 1/2 of this developed length from our 20 inches. Plus, we would have to subtract the gain, the shortcut here from that 20 inches. We'll be dealing with this a little bit more in depth later on. There's 2 ways to actually figure this setback out. One of them is mathematically, the other one is a practical application. What we're going to do is we're going to go put a 10-inch mark on our tubing. We're going to put that on the bend line on our shoe. We're going to bend this up at 90, and the difference between the 10 inches and what we come up with a total stub height after we make that bend is going to be the setback for that particular shoe. Now we're going to get down to some real serious stuff. We got our sleeves all rolled up and we're going to find our setback. To find the setback, the easiest way to do it is just take a piece of tubing and we'll come down here to 10 inches and we'll make us a mark. And I always like to take and circle a bend or a cut mark. That way it makes them real easy to find. After we've located our mark, we're going to go ahead and load the tubing into the bender. We just take our horseshoe here, and we don't worry too much about the mark. We slide our horseshoe on, drop our pin in, and then pull it back. Now our mark is right here, and what we're going to do is we're going to line that mark up right even with the face of this step. That'll always be where our start mark goes. Once we've got that done, we'll put in our follow bar. And our follow bar needs to line up so that it's also even with this face. Once we get it in, we line up our roller, drop our pin in. At this point, we're going to stop and make sure that the pin for our shoe, our horseshoe, and our follow bar are all the way down. Now we're going to go ahead and put some pressure on it. We're starting to bend there. At this point, we want to stop and stand the bender up. And the reason that we do that is so that we can accurately read our measurements on our degrees. we want to have put quite a bit of pressure on so that when we stand this bender up, all of our pins stay right where they belong. The other thing we want to do is we also want to raise this up, the back end up, so that it's level. So we'll just bring some blocking in here and put our little torpedo on here. We're a little bit short, so I'll throw my pencil in, and that brings this right to level. Now we can go ahead and take our smart level and just wait for us to come up to 90 degrees. Now, this is normally all done down on the floor, but it's a little hard to videotape there, and that's why we're doing it up on the table. We'll double check there, we're still level. And what we're going to do here is we're going to actually go past 90 degrees. And that's our 92 degrees right there. Now that we're at 92 degrees, we have to release the pressure on the ram to take out our spring back. When we were talking about it earlier, I said you just want to hit the release button and then make sure that it doesn't stay down, because that would retract the ram all the way, and that's not what we want to do. So we'll just take just a little bit of the pressure off, go over here and check. Our leg here is still level, and there we've got us a 90-degree angle. Now we have to measure it. So to measure it, we got to get it out of the bender first. So we'll be laying everything back down on the table. And you're going to notice that there's a lot of possibility of finger pinching here. Many times bending is done with a couple of guys around, and they always want to reach in there and they want to help you out. If you want them to remain good friends, please don't allow them to. Only one set of hands on the bender. This is an ironclad rule, because you'll notice opening and closing these things and moving everything around. It's real easy to get your finger in there, and then if your buddy thinks, well, this piece of pipe needs to be raised up a little bit, he raises it up and squash. You're no longer friends. So what we're going to do is take this out and get the bender off the table, and we'll measure and see what our stub height is. And to do that, again, we will be measuring from the top or the bottom of our bend here. To get a reference line, we're just going to take a piece of steel, lay it down right on the back so it's running parallel with our piece, and we'll go over here and we'll measure our stub height. Our stub height is 18 3/16 of an inch. So if we take our first 10 inches that we started with and we deduct that, we would come up with 8 3/16 of an inch as our setback. Once we know our setback for 90-degree bend for this shoe, then we want to go ahead and record it in a notebook. And this notebook becomes increasingly important as you work with your bender. Not only do we record what our setback for each individual shoe is in our notebook, but later on when we're doing offsets and kicks and multi-bends, we'll be recording that information in there as well. As you remember, we talked about bending being a plus or minus quarter of an inch process. Well, these records are going to be very valuable, because as you go through and say you bend up 6/90s and they all come out a quarter of an inch over, you'll know that you need to adjust your setback just a little bit. So now that we've got the setback for the 1.5-inch shoe, let's bend up a piece and see how we can use that information. Now that we know how to figure the setback for any given shoe, that makes bending 90-degree stubs as easy as eating Granny's homemade pie. So let's take a look and see what we would have to do to apply that to make us a 12.5-inch stub. So we want the distance from the top down here to the bottom to be 12.5. All we have to do is take our clean piece of tubing here, and we measure from the end of the tubing back 12.5 inches, and we'll make us a line. Then we'll take our setback back here, we'll deduct our 8 3/16 of an inch, we'll subtract that, and that will be our start line on our bender. That's all it takes. To lay out our 12.5-inch stub height on our pipe, the first thing we're going to do is come down here and make a line at 12.5 inches. This is not going to be a bend line, so we're not going to circle it. To get our 8 3/16 deduct in there, we're going to use a process called cutting an inch. It's very difficult to get the very end of the tape right exactly on the line. So what we're going to do is we're going to line up our 1-inch line with our 12.5-inch line. So we've cut or deducted an inch on the front. So we're going to go back here, and instead of making our mark at 8 3/16 of an inch, we're going to make it at 9 3/16 of an inch. So what we did was we deducted an inch on the front, and we added an inch on the back just to make things easier. So now we have our 12.5-inch line minus our 8 3/16 for our setback. We'll go ahead and chuck this up in the bender, put on our horseshoe, and drop in our follow bar, and we're ready to bend. After we get our follow bar in, we want to make sure that our pipe and our follow bar are both at our bend line. Go ahead and slide the roller in here, drop in that pin, and put some pressure on it. You notice that we lost a little bit here when we got down close, so we have to readjust things, making sure our line for our start bend is right on the place, the raised section of the shoe, and our follow bar is there, and we're ready to bend. Now comes the time of truth. Did we hit our bend? What we're going to do, we're going to measure it up, same way as we did before. We want to measure from the back of the pipe here to the top of our stub. So we take our straight edge, set it back there, and we measure up, and we came out to 12 3/8 inches. So that's within 1/8 of an inch of what we wanted. That's well within our plus or minus 1/4 of an inch for accuracy. Now that we know that our setback is accurate, what we're going to do is we're going to go ahead to the whiteboard and see what it would take to make this into a U-shaped bend. To make a U-shaped bend or a hoop or a back-to-back bend, we're just going to repeat the same process. What we're shooting for here is we want this hoop or U-shaped bend to have legs from the bottom to the top of 12.5 inches. So we've already been up one piece. We have the piece here. We want this side over here to be 12.5 inches. And then we want from the back of this one to the back side of this one to be 36 inches. So this is 36 inches overall. To accomplish this, we're going to use the same thing that we did over here. So all we have to do is before we wanted this to here to be 12.5 inches. We laid it out at 12.5 and we subtracted our setback or our 8 3/16. To make our U-shaped bend, we're going to lay our tubing in here like this. And we're going to take a straight edge and put right along the back side here. That's going to be our measuring point. That's going to represent the same as the end of the tubing on our first bend. Then we're just going to come down here at 36 inches, and we're going to make us a mark. Then we take from our 36 inches, we subtract our setback of 8 3/16 of an inch, and that becomes our bend line. So that when we put this in the bender, this is where the bend line goes on our shoe. When we lay out for our U-shaped bend, we want to make sure that our straight edge goes right against the outer part of our bend here. So pull that up tight, take our tape, and we're going to lay out for 36 inches. So we put our 36-inch mark on there. And again, that's not a bend mark, so we're not going to circle it. Then we take and deduct our 8 3/16 inch setback, and this is going to be the bend. Once we find our bend mark, we'll go ahead and check it up in the bender and give it a try. When we've got it all checked up in the bender and we've got our bend line right where we want it, then because we're making a U-shape, we're going to have to level a couple of things. The things we're going to have to level is the ram here. We put our level right on the ram and make sure that it's running level. Now we're going to go over here and we're going to actually level our stub that we've already bent. We've got just enough pressure on the ram to hold it and yet not hold it too tight that we can't adjust it. Once we've got both of these level, then we'll go ahead and bend it up. Now it's another moment of truth. Did we hit our bend? This time we've got to have a straight edge on the left and a straight edge on the right. We want 36 inches between these two straight edges. So what we do is we lay it out here, make sure our tape's running straight, and we got 36 1/16 of an inch. Boy, we're getting a little better at this. Now we want to make sure and record all this information in our bending book. Then we're ready to trim our end here. We want it 12.5 inches, just like this side. So all we do is we lay our straight edge on here, come over, put our 12.5 inch mark here, and that's going to be our cut line. So what we've done is we've bent a U-shaped bend. We got this come out to 12 3/8, and we were shooting for 12.5. We wanted it 36 inches wide. We're a 1/16 of an inch over there. And the only thing we did is we made one trim here. That's pretty good bending. We've just seen how we can do things the practical way. Now I'm about to show you how you can do it mathematically. And I'm doing this because I wouldn't feel good going home tonight knowing that I didn't complicate your life just a little bit. So when we do it mathematically, there's a couple things we have to work with. One of them is the developed length, the other one is the gain. Remember that the developed length is the amount of tubing that's actually being done. So it would be this amount of tubing right in here. To find the developed length for any bend, it would be 0.0175 times the degree of the bend times the radius would equal your developed length. So in the example we're using, it would be 0.0175 times 90, that's the degree we're bending at, times our radius. We're using an 1.5 inch shoe with a 7-inch radius. And if we did all that math, it would come out to 11.025. We also need to know half of that developed length. So we would just divide that by 2, and it would come out to 5.5125. What that tells us is 11.025 inches is going to be used from this point around to this point. If we were to change and say do it a 60-degree bend, it would be the same thing. Our 0.0175 times 60 times the radius of the shoe, which is 7, We would do that math and we would come out with the developed length of a 60-degree bend. Let's say we would change shoe sizes. We went up to an 1 3/4 shoe with an 8-inch radius. If we were going to bend it on a 90, it would be 0.0175 times 90 times 8, and that would give you the developed length for an 8-inch radius. The other thing we need to concentrate on is the gain. And the gain, you remember, is just the distance that we save by cutting across the lawn instead of going around the sidewalk. To figure gain, we need to get our gain factor chart. And don't worry, this chart will be listed at the end of the video, and you don't have to try and memorize it now. So all we would do is we would run down here to 90 degrees, we would look across, and the gain factor for a 90-degree bend is 0.4292. Once we have that figure, we would plug that into our formula. So it's 0.4292 times our radius, which is 7. We would do that math, and that would equal 3.0044. And that would be the gain on our bend. If we did happen to change this and say we wanted to bend a 45 on a 7-inch shoe, we would just run down our gain factor chart till we got to 45 degrees, go across and get that factor and plug that into our formula. Once we have our figures here, then we can go over here and figure out what it's going to take. You remember our distance on our stub height was 12.5. So we would take that 12.5, then we would take half of our developed length. Now you remember the center of our bend is right here, and half of our developed length goes from here to here, and half of our developed length goes from here to here. We're going to start with our shoe up here, or start at the beginning of our shoe up here, so we have to subtract half of our developed length, which is 5.5125. Then we have to take off our gain. Remember, we saved some tubing by cutting across the lawn rather than going around the sidewalk, so we have to deduct our gain. So that would be minus 3.0044. So what we've done here is we've taken our 12.5, backed up half of our developed length plus half of our gain, or our full gain. If we did that math, that would come out to 3.9835. Now, to find the start mark for our second bend, we would take our same 12.5, then we would add to it just 36 inches here. And we would plus 36. Now we have to take half of our developed length, because we have the same situation here, back up half of our developed length, which is 5.5125, minus our gain for this 90-degree bend, which is 3.0044. But we also have a gain down here on this first 90-degree bend. So we have to subtract that also. So that'd be minus 3.0044. When we did all that math, it would come out to 36.9787. That would be our two start marks. So what we could do is we could go out in the shop, we could take a piece of tubing, and we could lay out those two marks. The first one, 3.9835, we just come down here to 4 inches, and that would be the start mark for our first bend. Then we could go down here 36.9787, or basically 37 inches, put in our second start line for our second bend. We could bend those up, and we would come up with the same thing that we have here before we trimmed it. Now you'll notice that doing it the practical way is a little bit easier. This stuff we'll get into a lot more when we cover multi-bends. You'll also notice that there's a little bit of discrepancy between the mathematical and the practical way of doing it. That's what I was talking about this plus or minus. Anyway, this is food for thought that we'll use a little bit later on. Now that we've become so proficient at bending 90-degree bends, we're going to work on offsets. And the first thing we have to establish is that all offsets are measured center to center. So when we talk about a 10.5-inch offset, we're talking about it being measured from the center of this tube to the center of this tube up here. That would be our 10.5 inches. It's pretty difficult to measure from the center of a tube to the center of a tube, though. So what we can do is we can go down here. We can measure from the bottom of this one to the bottom of this one, and that'll be the same measurement, because what we're doing is we're coming from the center to the bottom and from the center to the bottom. We could also go up here and we could measure from the center or top of one to the top of the other. This would be our same 10.5 inches, because we're going from the center to the top on this one and from the center to the top on this one. So it's easiest to measure them bottom to bottom. Now that we've figured out how to measure them, let's talk about how to bend them. When we lay out for an offset, the first thing we need to establish is how much offset we need. So what we're going to do is we're going to come out here and we're going to say we're going to need a 10.5 inch offset. Next thing we need to know is if we start this bend here, where do we start this one? To do that, we just go to our offset table here, and it'll give some multipliers. If we're going to make this a 30-degree bend, then we would come down here to 30 degrees, we would look across, and we would see that the multiplier for a 30-degree bend is 2. So we would just take our 10.5 inches, and we multiply it by 2, and that would come out to 21. So that tells us that our bends have to be 21 inches apart. So we could go out here in the shop, we could take a piece of tubing, and we would go anywhere along this piece of tubing, and we could make our first bend mark. Then as long as we went 21 inches from our first bend mark down the tube to our second bend mark, we would be okay. So we could check this up in the bender, bend it 30 degrees here, flip it over, bend it 30 degrees here, and we would come out with a 10.5 inch offset. If we chose to do a 45-degree offset, we would do the same thing. We would go to our offset chart, we would run down to weigh at 45 degrees, we would look across, and the multiplier would be 1.41. So then all we do is we take our multiplier of 1.41 and we multiply it times our 10.5, and when we did that math, it would come out to 14.8 inches. So that tells us if we're going to bend this on a 45-degree angle, that our bend marks, instead of being 21 inches apart, need to be 14.8 inches apart. Now we need to discuss a little bit about gain in offsets. If you're bending from 30 degrees down, so 0 to 30 degrees, there's not enough significant gain to really worry about it. If you get over 30 degrees, you need to start worrying about it a little bit. On this particular offset, if we bent it without figuring in any gain, we would probably come out about 1/4 of an inch over. So on a 7 or 8 inch radius shoe, if you're bending around a 45-degree offset, you need to subtract about 1/4 of an inch. Laying out our offset requires 2 bend marks. So we're going to go ahead and put the first one here at 5 inches. And to make sure we know it's bend mark, we'll go ahead and circle it. Then we go down 21 inches between the first one and the second one and put our second bend mark here. Our second bend mark needs to be transferred to the other side of the tubing, because after we bend our first one, we're going to actually turn the tubing over 180 degrees to bend our second one. So after we transfer it around, we circle it, Let's chuck it up in the bender and bend it. We've got our piece of tubing in the bender on our first mark. We bent it up to somewhere around 20 degrees. Then we stood the bender up. Now we have to level the ram and make sure that it's perfectly level. Remember, we're going to be turning this piece of tubing over 180 degrees for our second bend. To keep out the dog leg, we want to be able to make sure that the ram is leveled, and we have to have something back here on the back part of the pipe to make sure it gets leveled properly. What I like to use is a piece of Kindorf, and this is available from electrical contractors, and it's just a U-shaped track here with a Kindorf clamp that goes on it. We're going to actually clamp this piece of Kindorf right to the tubing back here. And as I said, this tubing, or Kindorf and Kindorf strap, are available from electrical contractors. When you go to get one, make sure that you get 1¼ EMT strap, because EMT is measured inside diameter, and this tubing we're using is outside diameter. So we put our 1¼ Kindorf strap on there. We set our level right on here, and we just turn our tubing, or our Kindorf, until we're level. When we're happy with being level, then we go ahead and tighten it down good and snug. Now you notice this is back far enough that when we do our second bend, this Kindorf isn't going to be running into our follow bar here. After we've got that all done, we go ahead and complete our 30-degree bend. Our spring back and check, and we've got our 30-degree angle, so we'll go ahead and rotate it and bend our second one. We now have the bender set up with a second bend mark on our bend line on our shoe, and we've got just a slight amount of pressure on our ram. What this is going to do is it's going to hold everything in place but still allow us to level up our Kindorf. We want to first make sure that our ram is still level, and then we put our level down here on our Kindorf, and we want to take a pair of channel locks and actually turn the tubing. We don't want to be beating on our Kindorf because that's already been preset. So we set our channel locks on there, and we just twist this around until it's level, and then we can go ahead and really put some pressure on. Okay, we'll stop right there. Make sure our back part here is still level, and we'll go up here, and we want this to be level. So we're right there. Take out our spring back, and we've got it level. So we'll take it out of the bender and see how close we came. Remember, on offsets, we measure center to center. So when we put our straight edge on the bottom part of the tubing here, then we'll be measuring from the straight edge to the bottom part of the tubing up here. We measure it out, and it's 10½ inches exactly. If you can grasp and execute the concepts of this next bend that we're going to be doing, you will be able to bend anything, anywhere, anytime. In other words, if you get this, then you've got bending principles down pat. And I'm talking about really down pat. You'll be in the top 5% of people that use benders. And that's not the top 20, not the top 10, but the top 5. What we're going to bend here is a series of bends, all on one piece of pipe. We're going to lay them all out before we ever start, and then we're just going to chuck them up in the bender and bend them boom, 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 one right after the other. So when you master this, you'll have her down pat. All it is just a series of formulas that we're going to put together to find out where we put our shoe at. Our project bend here is going to be a rear hoop, and it's going to be a 4-bend hoop. So in other words, we'll have 180 degrees in 4 different bends. The material we're going to use is 1 3/4 tubing, And that's a change from what we have been using. We've been using 1.5 inches. Our specifications here is it's going to be 39 inches from the center of our top piece here. So we're going to actually have the tubing laying in like this. So if you're going to measure from the top, you're going to have to add half the thickness of the tubing that you're using. But from the center to the bottom is going to be 39 inches. And then from the center of this leg to the center of this leg over here is 43 inches. 43.25 inches, excuse me. We're going to come from the bottom of this leg up 25 inches, and we're going to put us a 10-degree bend right there. Then we're going to go up here, and this is going to be an 80-degree bend. Over here, we're going to have a 60-degree bend, and down here, we're going to finish up with a 30-degree bend. This 30-degree bend is also going to be 25 inches from the bottom of the leg to the center of the bend. To start with, we're going to have to take and lay this out to scale. And we want it as exact and as close as we can get it. So I like to do it actually full size. And that's what this big line here is representing, a scale model of what we're doing in here. We've got it, these actually 43.25 apart. We're 39 inches from here to here. We're 25 inches to the center of this bend and the center of this bend. Now you notice we have no bends here because the very first thing we have to do is we have to find out where the center of these bends are. So to do that, we just run our line straight. So to lay it out, we made these 43.25 apart. We just came up 25 inches, took this line out 10 degrees. Over here on this side, we came up 25 inches, took a line 30 degrees up. Where these lines intersect are going to be the center of our bends. So when we get done, actually, this thing will look something like this. To lay this all out and find out exactly where we put the shoe for each one of these bends, we're going to have to go over and use some formulas. And the formulas that we need to work with are, the first one is developed length. If you remember earlier, we said that the developed length for any bend is 0.0175 times the degree of the bend. Since we're working with a 10-degree bend, it would be times 10 times the radius. This 8 is the radius of the 1.75 shoe that we'll be using. And that equals 1.4 when you do this math. We're going to be needing the half of the developed length. So we're going to use 0.7 here as half the developed length. Down here on the 80 degree, same thing. We take our constant times the degree of our bend times the radius equals 11.2. Half of that is 5.6. On our 60-degree bend, we do the same thing. We come out 8.4 for a total developed length, 4.2 for half of that length. 30-degree bend comes all out the same, 4.2 and 2.1. The other thing we're going to need to work with is what's called the gain. As you remember, every time we make a bend, we gain pipe or tubing on that. To figure out our gain, what we have to do is we have to take our factor off of our gain chart times the radius, and that will equal how much material we'll gain. So we just simply take our sheet here, we come down to 10 degrees. It tells us that our gain factor for a 10-degree bend is 0.0008. For an 80-degree bend, it's down here, and it's 0.2819. Same thing with the 60 and the 30. So when we do all this math, we come out that the gain on a 10-degree bend is 0.004. That's not really enough to even worry about. 80 degrees is 2.26. 60 degree is 0.86. 30 degree is 0.1008. Now you'll notice that the higher the degree of bend, the more gain we get. On our 10 and our 30, we have very small amounts of gain, but up here on our 60 and our 80, we're getting a lot more. So now that we have these formulas, we can go back here and we can figure out exactly where we want to put our shoe. So we'll take this off the board here real quick and write our formulas right in the center here. After we have laid this out, we know that from the bottom to the center here is 25 inches. We measured it from here to here, the center of the 80 degree bend, and that came out 14.19 inches. From the center of this bend to the center of our 60 degree bend, and that's this distance from here to here, is 32.25 inches. Then we measured from the center of our 60 to the center of our 30, and that was 16.125 inches. Once we have all of those lengths, then we can set about figuring out where we want to place our shoe. So the first thing on our first bend, we take our 25 inches, and then we have to subtract 1/2 of the developed length. So we go over to our chart, or our formulas over here, and 1/2 of the developed length of 10 degrees is 0.7. Then we have to take our full gain. Well, our gain is 0.004. That's not even enough to worry about. So again, we take this length to the center of our bend minus 1/2 of our developed length, because remember the shoe is going to start here and it's going to end here. So we have to take 1/2 of that minus our gain. And since our gain is virtually nothing, we're going to take that out of our formula, just for this one where the gain is nominal. So our first bend is going to be at 24.3 inches. To figure out our second bend, we have to take our first length here, which is 25, add to that our second length, which is 14.19. Then we have to subtract 1/2 of the developed length of the 80 degree bend. Because this is the center of our bend, we have to come back here 1/2 of the developed length, and that is 5.6. So we take 5.6 away from that. Then we have to deduct the gain that we've got in this 80 degree bend. The gain on an 80 degree bend is 2.26. So we subtract 2.26. Next, we have to take the gain down here that we got from this 10 degree bend. Since it was virtually 0, it'd be minus 0 equals 31.33. So this is where our shoe would go, or our starting point for our shoe would go for our 80 degree bend or our second degree bend. For our third bend, we do the same thing. We take our 25 plus our 14.19 plus the distance from the center of our 80 to the center of our 60, which is 32.25. Then we subtract 1/2 of the developed length for our 60 degree bend, which is 4.2, minus the gain that we will get in this 60 degree bend, which is 0.86, minus the gain that we got from our 80 degree bend, which was 2.26, minus the gain that we got off of our 10 degree bend, minus 0. We do all that math, and it's going to come out to 64.12 inches. For our fourth bend, we just keep stacking our formulas together and we'll come out with it. We have our 25 to our 10 degree, plus our 14.19 to our 80, plus our 32.25 to our 60, plus our 16.125 to our 30. Then again, the first thing we have to take off is 1/2 of our developed length, which is 2.1, minus the gain from a 30-degree bend, which is 0.1008, minus the gain from our 60-degree bend, which is 0.86, minus the gain from our 80-degree bend, which is 2.26, minus the gain from our 10-degree bend, which is 0. And now that math is going to equal 82.24. So as you can see, we've just stacked everything together. We've just gone through and we've come out with where our 4 bends are going to start. You might be saying, well, why did you keep putting that 0 in our formula? I put it in there because if this had been a bend down here, say a 45, and it had a significant gain factor, you got to remember to put it in there. If you don't, then these bends aren't going to come out. So what we're going to do now is we're going to go lay these out on our tubing, chuck it up in the bender, and see how close we came. We've just spent a tremendous amount of time developing where we want these bends to go. So it's time to lay them out on the tubing here, and we start from the end, and our first one comes back 24 5/16. This time we circled them with a blue felt pin so we make sure and don't lose them. Second one is 31 5/16. Third one, 64 1/8, and the fourth one is down at 82 1/4. We've got our bends all laid out, but we also have to have our leveling device on. Since we're on 1 3/4 tubing now, we have to go to a bigger Kindorf strap. Here we're going to use a 1.5" EMT strap with our same piece of Kindorf. Well, we're all ready to chuck her up in the bender, so let's get after it. If there has ever been a time that you want to be very, very meticulous with making sure and hitting your marks and bending to the exact degree, this is the time. A very minor change in any one of these bends is going to make a major difference in our overall outcome. We're on our first mark here, and we've brought it up to 11 degrees. The reason we stopped at 11 is because anything under a 20 to 30 degree bend isn't going to have near as much spring back as, say, a 60 or 90 degree bend. So we stopped at 11 degrees. We're going to release our ram, and that drops us down to a 10 degree angle. Let's go ahead and slide it forward, and we'll do our second bend. Our first bend was a 10 degree bend, and our second bend was a 80. That brings us up, so our stub here is at a 90. So we want to bring that over to 92 degrees, so when we release it, it'll come back to an exact 90. Again, we're making sure of hitting our mark and our degrees just right on the button and making sure our Kindorf stays level. That way we won't have any dog legs. Let's go ahead and release the spring back. And we've got a 90 degree bend, so we're ready to start for our third. We bring our third bend up to 62 degrees, and we're ready to release the spring back on it. And there we've got our 60 degree third bend. That leaves us just one more, and we'll be home free. At our fourth bend, things got pretty precarious. Had to go out and dig up a piece of pipe here out of the boneyard to slide inside of the tubing that we're bending. And we were using this for counterweight. Otherwise, this whole thing would want to tip over. One of the dangers of bending. What we did was we brought this leg, this vertical leg here, up to 90 degrees exactly, and we stopped. This is because this is our final bend. We can actually use what would normally be taken up as spring back to adjust our whole situation here. So we want to go down here and measure to make sure that we've got our 43 1/4 center to center measurement. So to measure it, 43 inches center to center would be the same as measuring from the top of this leg to the top of our upper leg. So we'll go ahead, put the tape measure on there and run it up, and it's just a skosh under 43 inches. So we're not going to take any more bend there. All we're going to do is we're going to release our spring back. And we'll go over here and measure it again. And that puts us just about 43 3/16. That's close enough for me. What we're going to do is we're going to take it out of the bender, lay it down, and get a very accurate measurement on it. Now, if we had bended up and we had been too wide, in other words, we had been more, what we could have done is taken some more bend in our 60-degree bend or our 80-degree bend. Either one of those would have helped to shrink those down. If we would have been too narrow, then all we can do is pull it apart. So let's go ahead and unload it out of the bender and see what it looks like. Now that we've got it out of the bender, we can lay it down here and get some accurate measurements. What we want is we want 43 1/4 inches center to center. So that'd be the same as measuring from the inside of this leg to the outside of this leg. So we'll lay our tape in there, and when we measure it up here, it's 43 3/16. Back here, it's 43 1/4. So we're off a 1/16 of an inch. But in making a U-bend out of 4 different bends, 1/16 of an inch is close enough for me. We actually left these legs a little bit long because when it sits in the race car, and this is a hoop for the rear hoop for a race car, it sits at an angle. So we're going to have to trim those. That's all we have left to do to put this thing in the car. I think you'll agree with me that we've gone from benders of wild guessing to educated wild guess benders. And that's a good feeling when you can put your material in the bender, all marked up, bend it up, take it out, and it's pretty darn close. Well, I'd like to thank you for spending time with us. I hope this has been educational and entertaining. As for me, I'm going to go trim this thing up, stick it in my race car. Happy bending.